All right, so today we are going to explore some more simple and compound interest problems. That includes compounding continuously. You can go ahead and start by trying the warm up on your own and then unpausing the video and checking to see how you did. Okay, here you go. All right, so the parent over here, oops, that's an eraser, not what I want. So this is my parent right there, the points that are for the parent. And then there's my rule and how the points have changed. One was off the graph, but we get the idea. Okay, so remember we're using these formulas today. We have simple interest, which is the first one, that's for growth. And then there's decay to the right of that. That's the only difference between that is a plus and a minus on your rate. Compound interest is when you divide your rate by the number of compoundings and multiply your time by the number of compoundings. And then if it's continuously compounded, remember this is for population growth, bacterial growth, radioactive decay, then you would use that PERT formula. So I'll be looking out for those words and then we'll see if we can catch them and make sure we're using PERT for those. All right, so this says, Laura invested $2,000 in an account that pays 6% annual interest. Find the balance after 3 years if the interest is compounded with the given frequency. I would love to find these accounts that have 6% interest. How amazing. Okay, so annually, that means that the number of compoundings is 1, so we could just use simple interest. We don't have to divide by 1 and multiply by 1. So A equals 2,000 times 1, and then this is interest, so it's earning 6% to the rate times time. So 1 times the time, which is 3 years. That's my formula for that. So what I'm going to do is I'm going to do all of my equations, and then I'll get all my answers using my calculator. Okay. Quarterly would be A equals her 2,000 times 1 plus, oops, I forgot my 1. 1 plus the 6% divided by 4 for quarterly, and then the year is 4 times 3. And then monthly area equals 2,000. 1 plus 0.06 monthly is divided by 12 and then times 12 for 3 years. Okay, and then I have to remember when I put this in my calculator, I'm going to put parentheses there, put 12, parentheses there, and put 36. Okay, now I'm going to get all my answers here. Okay, good, calculator. All right, so here, excuse me, the first one. 2,000, parentheses, 1 plus 0.06, close the parentheses to the third power. Remember, this is money in account. Always reread that because if it was people, first off, it would be population. I'd be using PERT, but also I wouldn't round people to the nearest cent. All right, so this is 2382.03. Okay, the next one here, 2,000. 1 plus parentheses 0.06 divided by 4, close the parentheses twice, bring it to the 12th power, hit enter. We got 2391.24. 2391.24. And now for the last one, I can retype the whole thing or I can hit second enter and then bring up those numbers and toggle through and change the 4 to a 12. For my 12 months, okay, I should have just retyped it, right? 12 parentheses, to the, is the 2 that's still there? No. To the, and then I need the 36th power. And I hope I didn't make a mistake. That looks ridiculous. So hopefully you didn't copy that down because no way did they make 17,000 just by compounding monthly. So clearly my exponent didn't go away. So I'm going to come over here and hit enter and see what the heck. See, it did 36 to the 12th. See, at least I'm thinking. Delete, 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 enter, go to. Oh, I should just start this video over, huh? Delete, there we go, enter. 2393.36. Ask me if I'm ever going to do it that way again. Nope, I'll be retyping. 2393.36. Never again. That was a nightmare. Okay. Next, ooh, it's highlighted for me. There's no way I'm going to miss it if it's highlighted. Okay, so this next one says, the growth of bacteria, highlight, so that should be telling me that I should be using PERT, makes it necessary to time date some food products so that they will be sold and consumed before the bacteria count is too high. Gross. Suppose for a certain product, the bacteria is growing at a rate of 11.6% per day. There are currently 500 bacteria in the culture. How many bacteria will there be in a week? So once again, we're going to use PERT. A equals P, which is your initial amount, times E, which is Euler's number. That's going to be our base there, to the rate times time. Okay, so that's what we're going to be using. So we're looking for how many bacteria are there. The initial amount is 500 times E to the, and then we need the rate, which is 11.6% written as a decimal. That's 0.116 times the time. So how many will there be in a week? So I am not putting one. I am going to have to use days for this, right? Because it's either days, minutes, or years. We don't really do weeks. So we're going to do 7 for 7 days, okay? Oh, and also why? Because it says per day, right? It says 11.6% per day. So if I'm using the 0.116 per day, I have to have my time in days. So we're going to use 7 days because that's how long a week is. Okay, that makes sense too. 500, I guess I could have used week and then turned that, no way. Divided it by, no way. All right, 500 times E to the 0.116 times 7. Make sure the times 7 is in your numerator, oh gosh, my exponent. Make sure it's up there and not like falling down. All right, now this is bacteria. So we could have a discussion here about, can you have part of a bacteria, or should I round it to the 3 decimal places? I would say if it was people, we would just truncate it, 1126. Bacteria, let's round to 3 decimal places. It will tell you in your directions on your test how to round. Either yes, 1126.204. If you truncated and put 1126 bacteria, I would not be mad at you, because you could argue all day that it's not part of a bacteria. All right, how much bacteria was there a week ago? So time is negative, right? A week ago time is negative, so that's going to be a -7. So A equals 500 E to the 0.116 times -7. Area, I keep saying area for A. That's what happens when you teach geometry too. If you think I'm going to do second and replace that, you're nuts. All right, E to the 0.116, nope, I already hit the negative, not that it matters, times -7. Okay. 221.985. 221 would be fine too. Truncate, meaning just get rid of the decimal, because there's not 222 bacteria. I haven't decided how I would want my answer on that one yet in life. It's been years. Okay. All right, let's go ahead and move on to the next one. We are doing radioactive lead. Radioactive lead is radioactive decay, so we're going to use PERT again. A sample of 500 grams of radioactive lead-210 decays to polonium-210 at a rate of 3.2% each year. There's our units, right? Write a function that describes the amount left after t years. So once again, this is PERT. So we're doing A equals or Y equals, I don't care if you put either one. Your initial amount, which is our 500 grams, times E to the rate is 3.2%, and it's decaying. So we're using -0.032, and then t years. There's our equation. How much of the substance would remain radioactive after 20 years? So now we're going to do A equals 500 E to the -0.032 times 20. Okay, time to use my calculator. 500 again. E to the -0.032 times 20. And you get, remember it's decaying, so make sure your answer makes sense. 263.646 grams. So yeah, we're gonna be, it was grams, right? Yeah, because it was 500 grams decaying. It makes sense. If I would have got 17,000, I know I would have typed something wrong, right? Okay, more examples here. It says the original price of a new cell phone was $730. Right, that was the original price, P. After 2 years, the phone is worth $485. That's the final amount. And we got the year. Find the rate. Round to the nearest hundredth in which the phone's value is decreasing. This is simple interest, right? So I'm going to put down my equal sign. I have the initial amount is $730. I have the current amount is $485. Times 1 minus, because it is depreciating in value. We're looking for a rate, and then the time was 2 years. Okay, now we have to solve for R. So to solve for R, it's strapped inside that parentheses. I need a square root, but I can't square root yet. I'm going to have to divide by 730 first, okay? So I have 485 divided by 730 is equal to 1 minus R to the second power. Now to get rid of that, to get rid of that square, I'm gonna square root. So I'll square root this. And let's see if that gives us a nice answer. So first off, 485 divided by 730. See this decimal right here? Don't write it down because you will have to round at some point. So square root that. Hopefully good things happen here. No, they didn't. Okay, so that is negative. No, sorry, that's negative. I can read. That's 0.815097327 whatever. Okay. I was hoping it'd be a pretty answer, but still, it's not nice. Okay. So that is what 1 minus R is equal to. Square root of 485 over 730. I just don't want to round too soon, right? Now I'm going to subtract 1 and then divide by negative 1. So we're going to do R equals the square root. I didn't write that big enough. The square root of 485 over 730 minus 1 and then divided by negative 1. That looks beautiful. Okay, let's get that R value. So let's do that. I already did the square root. That's that. Minus 1 divided by negative 1. Oh, don't worry. Oh no, I gotta retype it. It's okay though. All right, 485 divided by 730. I could get it back on my screen, but I'd rather just redo it. Square root of that, square root of second answer. All right, now I have to do minus 1 and then divided by negative 1. And I get that is my rate. I want to turn it into a decimal. So we're going to do, or sorry, it already is a decimal, but I want to turn it into a percentage. So I have moved the decimal over 2 places, that's 18, and then I want 3 decimals on my answer, so 490%. Oh, goodness. Oh, goodness. Okay. Alexandra has $2,225.75 in her bank account today. If she earns 2.5% interest each year on her investment, how much was in her account 6 years ago? All right, so there's multiple ways to write this, okay? I'm going to show you 2 different ways, and then you can decide what to do. So 6 years ago, you can look as T is negative 6, and you can say that this is her current amount, right? So you can say A equals 2250.75 times 1 she was earning, so that's plus 0.025, and then 6 years ago is negative 6. So that's one way of doing it. Or you can do 2250.75 is equal to, and you're looking for how much money she had, so that's P times 1 plus 0.025, and then I want to know how much money she made in 6 years, right? Both of these will give you the same answer, and I'll show you that in my calculator, I hope. 2250.75, parentheses, 1 plus 0.025, close the parentheses, to the negative 6th power. So I'm going to write down the answer. So she started off with 1940.81. But I could also, to get P by itself, divide 2250.75 by this. Okay, so I can put that in my calculator. 1.025 to the sixth. Enter. And then I can do 2250.75 divided by that. Second answer, 1940.81. It gives you the same answer, right? So just make sure you write down an equation that actually works. All right, next one. Chrissy invests in an account that earns 5% interest rate each year, compounded monthly. If her account has $671.49 after 4 years, what was the initial value of the investment? So we could do it just like the last one, right? So we could say we're looking for the initial investment. She now has $671.49. All right, we're looking for the initial investment. She is gaining 5% compounded monthly. And this is 12. And then how many years? 4 years, right? So 4 years have passed. And we can put this in our calculator and divide both sides by that, okay? Or we can change that to a -4, right? And we can say that we're looking for the amount. So we can say the current amount is 671.49. 1 plus 0.05 over 12 to the, and then say that it was 4 years ago, so times -4. Both will give you the same answer, okay? Just to show you, to make this video extra long, 671.49 times 1 plus extra parentheses, extra parentheses, 0.05 divided by 12, close parentheses, to the -48 power. And then I'm just going to write that down because I know what's the answer. That is $550, all right? Because if I round to the nearest cent, that's 99 cents, but move it up to $1. And if I do it the other way, I would type this first, 1 plus parentheses, 0.05 divided by, I forgot my original parentheses, 1 plus parentheses, 0.05 divided by 12, close parentheses, to the +48th power, enter, and then 671.49 divided by that is same thing, okay? All right, if there's more than one way to do something, I'm not gonna keep typing it 2 ways. If you get the same answer, you're fine. 2 problems left. The temperature of a cup of hot chocolate in a room can be modeled by T of M equals 75 times E to the -0.05 M plus 70, where T is the temperature in degrees Fahrenheit and M is the number of minutes that have passed since the cup was made. What was the temperature when the cup was first made? All right, so there's 2 ways of thinking about this. Hey, graph this. All right, so if you thought about, hey, graph this, there is a horizontal asymptote at 70. It's exponential decay because the coffee cup is getting colder. Sorry, the cup of coffee is getting colder and colder and colder, right? And you can figure out what the y-intercept is. That's one way, right? But I am going to instead say I'm going to plug in 0 for M, right? I'm going to plug in 0 for M to see how many minutes have passed, 0, right? So we have, because that's what it asks us to, T of 0 is equal to 0 minutes have passed when the cup is first made. 75 times E to the -0.05 times 0, and then plus 70. Could use a calculator for this, but I know that this is 1, all right? Anything to the 0 power is 1. And 1 times 75, 75, 75 plus 70 is 145 degrees Fahrenheit. Okay. What is the temperature after 35 minutes? T of 35 equals 75 times E to the -0.05 times 35 plus 70. This better be less than 145 degrees or I typed it wrong, all right? It's cooling off. E to the, because it's cooling continuously. It should be like, ah, yes, that makes sense. Times 35. Get out of your exponent. Plus 70. 83.033 degrees Fahrenheit. The end. All right, hopefully that was an extremely long screencast for you, and hopefully you fast forwarded through me talking a lot, but go ahead and work on some homework.